In part 3 of the series, we will create a character controller with C# that utilizes Unity physics. We will also cover the basics of creating and applying materials to objects. We'll just start off just by deleting these cubes. We don't need them anymore. And we can go into our scripts folder, we can delete this test script. Okay. So Unity has a built-in physics engine that handles collisions and all that kind of stuff. And for this project, for this game, we are going to be making a ball roll around, which can actually be controlled using a keyboard. So just to give you an explanation of how, on a basic level, Unity physics works, is that you have colliders and rigid bodies. So as an example, let's start off with, as a simple example, let's start off with a cube. And let's create a sort of platform or a floor. So we can select the scale tool. And let's scale this out. Let's just say 10. And you can see here, we can actually type it in here, 10 by 10. Like so. And if we want to, we can actually click here, just sort of single click, and we can change, we can call this floor. And when you create a cube, or any of these 3D, well, most of these 3D objects, cubes, spheres, capsules, and such, it will by default will have a mesh filter, mesh renderer, and box collider. So the main ones being the mesh renderer and the collider. So the mesh renderer is what actually renders the mesh. So if we disable this component, we can actually see that it's not rendering the cube mesh. It's still there, the collider is there and still working, however we just can't see it. And then the box collider, which is for collisions. So if we hit play, nothing will happen, it will just stay there. There are no physics. So if we want to actually enact some physics, we can create a new 3D object. Let's just make another cube. You can see here it's actually underneath. If we bring it up here and just move it across, we can bring it up a little bit more. Same thing, it has a box collider. But if we actually want some physics, we have to click add component, and we want to find rigid body. You can search it, or you can go select physics. You can see all this, you have a whole menu here of all the different components you can add. So we can go, this will be found in physics, and rigid body here. These are the default values, you can leave them as that, and then you have use gravity, which is already ticked, and is kinematic. You tick that if you don't want it to move, you want it to be completely static. But just for using gravity, if we now hit play, we can also set up our, if we wanted to, we can set up our camera in the way we want it. Let's just move our camera up a bit. We can view it through the scene view. We would just have to click back, but let's just click play with the game window selected. If we hit play, we'll see the box fall and it will stop. So for a physics interaction to work, one of your objects needs to have a rigid body. At least one of your objects needs to have a rigid body on it, and the other object doesn't need to have a rigid body. They can both have rigid bodies, that's fine. But you can see here, if I Let's see, if I remove the box collider, our rigid body will actually just go straight through. So it needs the box collider as well as the rigid body. You could see the physics was still working, but there was no collision being detected. And also these colliders have a trigger option. When ticked, objects can actually pass through the colliders, but there is a method which we can actually call or have called, so that we can know if any objects pass through the collider or pass through the trigger. All right, so we're not working with a cube. Our controller, or our character, is going to be a sphere. So let's delete this box, and let's actually start by creating a sphere. Let's move this up. Okay. So it's got a sphere collider. Go back, we can add a rigid body, and we need to create a script to actually be able to trigger forces to move the ball around. So what you can do is you can actually just go straight here, add component, new script, and we can just call this player controller. Click create and add. When you create a new script through here, it'll actually just appear here in the root assets folder, but we can actually just move it over to our scripts folder like that. Cool. Just appears to be, oh, okay, cool, it's just thinking. And let's go in and edit our player controller script. So the first variable that we will need to reference is the rigid body. So we'll start by typing in private rigid body, and we just call this, RB. It's good to keep these things short. And then we want to actually assign something to this rigid body. Right now it is null. It has no value. So if you actually look in the inspector of our sphere, you can see the script that we attached is here. But what's actually also attached is the rigid body component. So the rigid body is attached to the same object that the player controller script is attached to. So we could make the property public, and then we could drag the rigid body in. So if I made this public, we could go here. We could actually take our rigid body and drag it in. So now it actually is referenced. Or, which can be this can be a little bit more handy. If you don't want to drag things all the time, you can actually set that to private. And in the start, we can actually say RB equals get component rigid body. And just through code, it will automatically look at the object and find the rigid body component that is attached and assign it, rather than having to drag it. And it will do that at the start each time. So you don't have to worry about that. Cool. So for the next part, which is actually enacting forces on our sphere, on our rigid body, we're actually going to use a thing called fixed update. So if you just type in void fixed update, You don't have to have this access modifier here on the method. You can I like to get rid of the access modifiers for these Unity methods, just so it differentiates them from my methods that I create as opposed to these ones from Unity. So fixed update works kind of like update, except it will run at a fixed rate. So I'm not entirely sure how many frames the fixed update will run at per second, but it will be the same every single time, which is great when we're enacting force or adding force, is because no matter what machine you run this on, or no matter how fast or slow your computer's running at the time, you will get a persistent result. Because if you're, say, enforcing a certain amount of force on an object every single frame, then the more frames you have, the more force you're going to be enacting, and then your object will be rolling and being pushed faster on certain computers than other computers. So by putting in fixed update, it will always be rolling at the same speed on any machine. So first of all, we want to get the input. So if also, this is actually an opportunity to talk about where you place your variables. So if you list your variables up here, then I can actually reference RB anywhere else in the script. However, if I list a variable within a function, like within here or within here or within here, I can only reference it with other code that is also within this method. So if you have a variable and you don't plan on using it or referencing it anywhere else in the script other than just that one method, then you can actually declare and assign, or you can declare your variable within that method. So we're gonna declare a float, and we're gonna call this move horizontal. Oops. Cool. So we have move horizontal, and we're going to say equals input dot get axes horizontal, and then we're going to have another one called move vertical. Now, we're not actually going to be moving horizontal and vertical, but rather forwards, backwards, left, and right. But we're just using these names, horizontal and vertical, because that is the default names that Unity sets in the input settings. So if we go to our back to our Unity project, we can actually look at these input settings in Edit, Project Settings, and go to the Input Manager, expanding axes. And we can see here we have horizontal and vertical, and you can see the names are here. So you can see horizontal is left, right, or A and D. So left and right arrow key, A or D, and you can change these controls if you want. And vertical being up, down, and SW, so down, up, or SW. So these are the default settings, but our up, down is actually going to be forward and back. So yeah, rather than up and down, yeah. Cool, so back to our code, we have declared a float called move horizontal, and we're going to get a axes. So get axes is mainly used if you're taking input from, say, something like a controller, like a joystick or something like that, where you can actually have a value between 0 and 1. If you move a joystick only halfway to the right, you know, you're going to get 0.5. Halfway to the left, you're going to get negative 0.5. And push something all the way to the right is going to get you 1, and all the way to the left is going to get you negative 1. And if you're not touching the joystick, it should be around 0. And so, but with our keys are on a keyboard are very binary. They're either down or they're up, so either 0 or 1. So our move horizontal and move vertical will have a value of either 0 or 1. 0, it's not being pressed. 1, it is being pressed. So what we want to do is we actually want to take our input and convert that into a vector. So a vector basically holds it's an array of 3 floats, x, y, and z, which is used, you can use that for, you know, position, scale, rotation, direction, you know, all of those. But we're just going to be using this vector 3 to define the direction of which we're going to add force, or in this term we're going to be adding torque. So we can declare a vector 3 and call it movement, and we say new vector 3. And so our x of the vector 3, because we're declaring a new one, so new vector 3 will be our move horizontal. Our y, which is up, well, 0. We're not going up. And our move vertical will be forwards and backwards on the z. So now we've taken our input and we've put it into a vector, and we can actually start adding force to our ball. So RB dot add, and we're going to, rather than adding force, we're actually going to add torque. So torque is like a rotational force rather than a directional force. So this is going to actually force the ball to start turning, and with enough friction the ball will start rolling. So we're going to add torque, and we are going to pass in that vector, and it's going to take that. Now, oh sorry, movement. Movement vector. That's not a vector. Now, if we actually want to adjust how fast or slow our ball will roll, we can create a public float, and we can actually call this, we can call this speed. Whoops. We can call it speed, or you can call it acceleration, whatever. That's fine. And we can then multiply our movement vector, because our movement vector is going to have a value between 0 and 1, or in this case 0 or 1, and we can multiply that by our speed factor. So if we're moving in the positive z axis by 1, we multiply that by speed of 10, we're going to be applying 10, I think it might be in newtons or torque or something like that. I'm not sure how Unity measures and what units for torque, but yeah. Cool. So if we now go back to our editor, selecting our sphere, or Why don't we call our sphere player? All right, now speed, let's just give it a speed of, I don't know, let's just say 2. We know that we will be enacting torque, a rotational force, on the Z axes. So if we actually move on the Z axis, we know we're going to be rolling this way. So this way is forward, and this way is left and right. So what we want to do is we want to set up our camera so that our forward facing of the camera is aligning with the forward direction that we're actually going to be rolling. Otherwise, forward will be left and right will be forward or backwards. It's not going to make much sense. It'll be very confusing. So what we want to do is we want to rotate our camera this way by 90 degrees. You type in 90 and then move our camera over here. And now if we hit play, you can use the arrow keys or the WSAD. Okay. Oh yeah. Sorry, the other way. So if I actually, because forward is in the positive Z direction, so if I start dragging this up and making this a positive number, we can actually see we're rolling in that direction. And then if I start dragging Z into the negative, then we're rolling in the other direction. So we need to turn this camera around 180 degrees. Cool. Whoops. So it's at 270. Cool. Let's bring this back here. Now if we hit play, now we can see pressing W will roll us forward, pressing S will roll us back, or the arrow keys or whatever you want to use, WSAD or the arrow keys. So now we have a ball that's actually rolling around. We can actually control it. The only thing is, and you can kind of do this however you like, but you may want to make a ball that is a bit more responsive or easier to control. So with Unity physics, to make a lot of the time in game development, you're going to be having to kind of, if you're using a physics-based approach to things, then you're going to have to kind of, I guess, change the physics or make the physics work in a very unrealistic way to get the results that you want. And that can involve a lot of fiddling around and just experimenting with different properties and all that kind of stuff to create a sort of the effect that you want. So I've actually spent quite a bit of time playing around with these settings and refining these to a point where that I feel is good for the character. So something that I want to do is I want to make my character a bit speedier, a bit faster. So I might change this speed to, I don't know, let's say 10. Now if I hit play, we can see I'm a little bit faster. I don't know, let's change it to 100. It's going to get even faster. Oh yeah. But it's not really that much faster. And that's because Unity actually limits how fast things can rotate. So if we want to be able to exceed that, rotational speed, we actually have to go back to our editor, and in the start here, we actually need to reference our rigid body and set our max angular velocity. And let's just make it so we can set that in the property, in the inspector, sorry. We can just call that max, ANG, for max angular velocity. And then at the start, we assign that to the maximum angular velocity. And if we go back and we actually set that, I think by default it's 7. If we set that to, just for example, we set that to 100, then we can actually, I think it's in radians per second, so we can spin up to 100 radians per second. By default, I think it's 7 or something like that. So now if we move, we are spinning a bit faster, although it's not very responsive because we don't actually have much traction. So if I go in the game view, tick gizmos on, so we can actually see our little ball rolling, I'm actually applying so much rotational force that we're actually spinning on the spot, almost like we're on ice. Just because we're just applying so much force. It's kind of crazy. So to stop us from slipping, we need to increase our friction. So all of our colliders will have a default physics properties, but what we actually need to do is create our own physics material for our player. So we're going to create, and we're going to go physics material. We can just call that player, and select our player, and then we're going to drag our player physics material onto our sphere collider. Select our player physics material, and we could change this to something like 4, which should give us a little bit more friction and a little bit more speed. Whoa, okay. So we are getting a lot more friction going on, which means more speed. Like that. A bit too much. And also, if we increase our mass, if we're heavier, we're going to have even more friction on top of that. So if we set our mass to 10, down here in the rigid body, we're a bit heavier, but oh, okay, we've got a bit more speed there. So what our current problem is that it's kind of hard to stop and it's hard to slow down. We don't have any brakes. Once you start rolling, it's really hard to roll back the other way, especially if you have too much momentum. So what we actually need to do is increase our angular drag. So that is going to limit, or that's basically what's going to slow us down when we are not enacting force. So our angular drag is 0.05. But if we increase our angular drag to say, I don't know, let's just say 20, or let's say 15, something like that. You see, we can actually, we're moving a bit slower because we're facing a lot more drag, but you can see we're actually, the ball is actually stopping. Once I let go, the ball actually stops because we've got all that drag slowing us down. So basically, to create this kind of responsive feeling of being able to move quickly but stop quickly, we essentially need to increase our speed quite dramatically So we're actually enacting a huge amount of force, but also increase our angular drag so that it's slowing us down faster as well. So now we're moving a bit faster, but we're almost, when I let go, we come to a stop almost, you know, instantaneously. Yeah. And if you want to limit how fast you can roll, you could also set your maximum angular momentum. What is it called? Maximum angular velocity. And yeah, you can set that to, I mean, I have it set to 9. That was fine for me. And that's what worked for me. And you can kind of play around with all of these different settings and try different things. But yeah, there's a lot that you can kind of play around with. Oh, sorry, I've made this change in play mode, so you can see it would revert that. So I'm going to go back to 9, and you'll get a similar result, but it just means you're not going to pick up too much speed. But yeah, you can kind of see I'm a little bit slower, but see how I'm stopping like pretty much straight away. I just stop. Cool. So that's pretty much the character controller done in terms of movement. So I think the last step we can actually do is give our character some color. So what we can do down here is we can say create material. We can say player, and then we can actually drag that onto our sorry, we're in the game view. You can actually drag that onto our player like that. You're not really going to see anything because it's the same color. This is just the default color. But actually, if I change this to, you know, if I select up here in the top right and then select something that's kind of like blue, you can see when I drag this in, whatever I drag it on is going to be changing that color. So now our player is blue. And just by changing the color here, we can make our character any color we want. We can make it black, white, blue, pink, and all colors in between. But I'm just going to go with a nice kind of blue. Maybe something a little bit lighter. Something like that. There we go. And we can actually, if you want something a bit more less reflective, you can change the smoothness, metallic. You know, if you want something that's very kind of almost like a crystal ball or something like that, you can increase how metallic it is. But I just, you know, I think it's nice just having a completely you know, no metallic or smoothness. Just gives us just a kind of a simple kind of shading. And yeah, now you have a blue ball that can roll around just like that. And while we're at it, in our game view, let's select our directional light and let's change that Y rotation. Change where the light, you can have some light more like this, and then we can change something like that. Change it to make it a bit, make it a bit brighter. Something, you know, you can play around with the light settings. You can change the color of the light. You know, you can do whatever you want, but you know, you can just something like that. It's fine. Cool. Oh, another thing. Now that we're at this point, we should actually save our scene. So by default, that scene that was opened when we created the new project is actually by default in the scenes folder, and it's just called sample scene by default. But let's just keep it as that. for now.